Good morning, students. In the previous session, we had learned a few concepts of OOPS, and today we are going to focus on some other concepts of OOPS, that is polymorphism, encapsulation, data abstraction, inheritance, and a few Java terms. Let's see what is abstraction. When we consider a situation of an ATM machine, we are never concerned about how the machine works or how does it accepts our passcode and withdraws from our account. The only thing we are concerned about is that we can draw money from an ATM at any time. Now, let's see this with the help of an example. In real life, uh, when we take a car, now we know that we are only concerned about how to drive a car, how to step on the pedal, brake, accelerate it or slow it down. We are also concerned about how to rotate the steering wheel to turn the car or to change the gear forward and backward. We are not concerned about the individual parts of the car, how they are connected to each other, as car is a very complicated machine and each part has a distinctive purpose. So what is abstraction? Abstraction is a mechanism to represent only essential features which are of significance and hides the unimportant details. For example, children, at your place, if you have a music system, you are concerned about how the which track has to be played. For example, you want to play track number 3 or track number 4. You are not concerned how the music system moves to that track, how the track gets uploaded and how it is played. You are just concerned about increasing the volume up or down, how the volume is increased, that you are not concerned about. So this is what is called as abstraction. Now let's see what is encapsulation. When we think of encapsulation, the first thing which comes into our mind is a capsule. Now what is a capsule? Capsule actually hides the inner medicine from the outside world. It gives us a cover to to hide the internal medicine which is there from the outside exposure. So if we say that the combination of a medicine are variables and methods, then the capsule will act as a class and the whole process is called encapsulation. We had learnt about class in the previous session. Let's see what are a few advantages of encapsulation. Now, it makes both data and functionality safe from the outside world. It helps achieving abstraction by providing a cover. It provides abstraction between an object and its clients. It protects an object from unwanted access by the clients. An example of this is a bank application which forbids or restricts a client to change an account's balance sitting at home. You cannot just change the balance on your own, or anybody else can't, unless and until you withdraw the money and the bank updates it itself. So encapsulation can be achieved further by abstraction. Let us understand this by taking an example. Now, children, when we are talking about email, now what happens every time you log into your email account, either it is Gmail, Yahoo, Hotmail or any other email account, you have a whole lot of process taking place in the back end and you don't have any control over it. So your password would probably be retrieved in an encrypted form, means in a form which is not shown to you. It shows you some dots over there when you put in your password. Verifies and only then you are given access. You do not have any control on how the password is verified and how this is kept safe from misuse. Now let's see how it is linked with abstraction. When you log into your email, compose and send a mail. Again, there is a lot of background processing involved, verifying the recipient, sending request to the email server, sending your email. Here you are only interested in composing and clicking on the send button. What really happens when you click on the send button is hidden from you. So we can say that abstraction can be achieved through encapsulation, as encapsulation binds together the data and functions that manipulate the data, keeping it safe from the interference and misuse. And abstraction is a process of hiding the implementation from the user. Only the functionality is exposed here. So you are aware only of what the application does, not how it does it. Now, how encapsulation can be achieved? Java provides different accessibility scopes, that is your public, protected, private and default, to hide the data from the outside world. So what are these publicity scopes we will, or accessibility scopes or access specifiers, we will look into more detail. They are default, protected, public and private. Let's see that. So let's take an example, and the Facebook is the best example to depict this. Now when in a Facebook account you have given the rights for your account to be seen to anyone. So in that case it is public. When your status on the internet is visible for public, then you have a public access specifier which makes it visible to anyone on or off Facebook. If you make the status visible only for me, then no one can see the status except you. That is your private access specifier. In the same way, when you have given the status as visible for friends or friends of friends, then your status will be only visible for your friends and your friends' friends, not everyone present on Facebook or internet. In that case, the access is protected access specifier. If you make the status visible for friends, then your status will be only visible for your friends, not your friends' friends or everyone present on the Facebook. Then that is a default access specifier. Let's take another example. Children, for example, you have a bank account. When you go to a bank, you ask for your balance. Not everyone in the bank is able to access your balance. So the bank account is private for you and it is not accessible to everyone. But if you go to a post office and you ask for some receipt of some let's say envelope, then that envelope or that stamp is accessible to everyone whosoever comes to the post office. Anyone can ask for it. So that is public for everyone. Now let's see the example of protected. Now the cash or the money lying at your home, it is protected for you, but it is not accessible to your friends outside your home. So your parents have kept that money for you, which is accessible to you in some limit. It is not accessible entirely but in limit. So your parents have kept it protected for you. So but the television in your house is accessible to anyone who comes in, if it is lying in the drawing room. If it is in the bedroom, then again it is protected for you. So this is what is meant by access specifiers. We set up a scope or a limit to what the accessibility can be done. Let's take another example, few more. For example, the street light or the road water. Anyone can access it, no restrictions at all, so it is public. Your mobile WhatsApp text is only you who can access it, so it is private. Your assets or properties, you will use your assets and your children will inherit them. No one else can use it, so it is protected. The television, I had given the example before also. Anyone who is allowed in your home can see the TV. You won't take your television or fridge outside when you take it. So outside your home, no one can access it even if it is you. But if you are not going to move it out, so it is always accessible by default to everyone. Let's see now what is polymorphism. Now polymorphism is, poly means many and morphism means forms. So polymorphism means many forms. So polymorphism provides for an entity to behave in several forms. In layman terms, an excellent example of polymorphism is when all of you are giving exam. Depending on the efforts put by you, you get a desired result. If the efforts are extraordinary, the result is excellent. If the efforts are less, result is poor. Whereas if efforts are more, result is good. So depending upon the efforts put in, we get an output. Now here efforts is the parameter on which the function result depends. Let us take another example. While driving a car, we can drive it at a speed of 20, 60 or 120. Now if we apply brakes, then either the car gets halt, slowdowns or skids. Now depending on the parameter speed the function apply brakes behaves differently. Children, now it's time for you to answer something. Let's see if you can answer. Consider a situation where you have to buy a car. Now, if you have more money, you will prefer buying a luxurious car of top model. If you have sufficient money, you will prefer a car in normal range. Now, if you have less money, you will buy a normal car with basic features. So, can you tell which is the parameter here and which is the function performed? Okay. Now, the answer to this is parameters is funds or money and the function performed is buying car. Now let's see what is inheritance. Children, you have often heard people saying that you resemble your mother or you have the same voice as your father. What does it mean? It means that you have inherited a few traits of your mother or father. But can you have your own unique features? The answer is yes. In the same way, we inherit properties from our ancestors. But does that mean that you can't buy your own property? No, absolutely not. It means whatever your ancestors had, that is protected for you, but you can buy your own property also. Thus, we can say that we have inherited this property from our forefathers and this is my own property. Thus, inheritance is a mechanism of deriving a new class from an earlier existing class. The inheritance provides a basic idea of reusability in object-oriented programming. The new class inherits the features of the old class and the old class and the new class is called given as pair, that is the base derived or the parent child or a super subclass. Inheritance supports the idea of classification. In classification we can form hierarchies of different classes, each of which having some special characteristics besides some common properties. Through classification, a class needs only definition of those qualities that make it unique within its class. In the example given above, we have a vehicle class at the top in the hierarchy. All the common features of a vehicle can be put in this class. For example, we can drive a new class two-wheeler or maybe a three-wheeler or maybe a four-wheeler from this vehicle class. As another example, we can take an engineering college as the top of the class and its various departments such as computer, electronics, electrical as the subclasses. The university to which the engineering college is affiliated may be its parent class. Let's see if you can also think of some inherited and base classes. Now, examples of inheritance. Now, in this example, you have an animal which is the base class and the cat and dog are two derived classes from this animal class. Now, the cat and dog have all the characteristics of a basic animal. It can breathe, it can talk, it can walk, it can eat, it can make sounds, etc. In the same way, we have an insect class and the bumblebee and grasshopper are different types of insects which have the basic specification of insects. So insect is a generalization and the specialization is a bumblebee and a grasshopper. In the same way, animal is the generalization and cat and dog are the specialization. So we can say that when we talk about inheritance, it is a relationship between base and derived class. It can be implemented by using extend keyword. It helps to reuse the code. The base class is called the superclass and the derived class is called the subclass. It can be achieved by the help of access specifiers as discussed earlier in this session. Now let's see what are Java tokens. Now we have many tokens as keywords, identifiers, constants, literals, strings, separators, punctuators and operators. We will look into detail how what these operators are and what these tokens are. Now let's see what are keywords. Keywords, also known as reserved words, are the words that have a special meaning to a Java compiler. A Java compiler reserved these keywords for its own use and hence they are not available as names for variables or methods. A few Java keywords are like default, if, public, which you have already learnt in class 8. We will learn many more in the coming session, and these words cannot be used as variable names. We will be looking into detail what is a variable in the next session. Now let's see what are identifiers. Identifiers are used to name different components of a program such as variable, methods, objects, classes, etc. There are some naming conventions for an identifier. An identifier can consist of any combination of letters, digits, underscore and the dollar sign. An identifier cannot begin with a digit. Identifiers may be of any length. Both uppercase and lowercase letters can be used in naming an identifier. Java is a case-sensitive language, which means that two identifier names that differ only in upper and lowercase characters are considered to be different identifiers. Therefore, total written in small case and lowercase and total written in uppercase or total with different cases are all different identifiers. Now let's see what are literals. Literals are a sequence of characters that represent values in a program and are stored in variables. Literals are made of digits, letters and other characters. Children, you have learnt about constants in the previous classes. So literals are nothing but they are constants in other words. But in Java we name them as literals, and identifiers could be variable names. As I had discussed earlier, it could be class name or it could be any other which identifies an object or a thing or a class or a name. Identifier is basically a name given to a memory location. It could be a class, it could be an object, it could be a variable name, it could be a method, anything, and the value which is stored in that is a literal. It could be numeric, it could be non-numeric, it could be boolean, it could be null. We will be looking into all these values later. Now what is string? Strings are nothing but they are tokens which are considered as a string. They are we will be learning much in detail about strings in class 10, and basically they are divided into, each sentence is divided into tokens and each token is stored separately. They are enclosed in double quotations. Now separators and punctuators. Separators and punctuators are the punctuation marks which are used or the symbols which are used to group or separate a code. We already know a few separators like semicolon, comma, period, etc., and we will be learning a few more in this session and a few more later. So you know that semicolon is mostly commonly used as a separator in Java and it is used to separate statements. It is used to represent the end of a statement basically. Comma is used to separate consecutive identifiers in a variable declaration, especially when we are passing it as parameters. Let's see few more examples of now operators. Now, what are operators? Operators are nothing but are symbols which are used to perform arithmetic or logical operations in a given expression. The variables or literals or values are combined to build an expression. The variables or literals on which an operator is applied are known as operands. An operator needs one or more operands to perform any operation. For example, when we write a plus b, now here a and b are the operands and plus is the operator. So there are a few operators which are unary and a few operators which are binary. We will be looking into more detail on the unary and the binary operators later on. These are some unary operators which are mentioned on this slide. Assignment operator, that is your equal to operator. Arithmetic operator, that is your plus, minus, multiplication, division and percentage. Relational operators are the symbols which we are using for comparison. The increment and the decrement operator, the logical operators and, or and not, and then we have the bitwise operators and the conditional ternary operator. The bitwise operators are not a part of your syllabus. Now let's see what are data types. Now data types are nothing but you had already studied few literals. We had seen about the data types in the previous slides wherein I had mentioned about float, integer, etc. So we are going to look into more detail of what are data types. Now Java has a variety of data types that allow programmers to pick the data type suitable for the need of the application. Into the following categories as primitive data types and non-primitive data types. Integer, floating point, character, boolean, these are all primitive data types. These are further divided into the following categories. We will be looking into detail very shortly. The non-primitive data types are the classes, interfaces, arrays and strings. These are a part of your, a few of them are a part of your syllabus this year and a few of them are part of your syllabus for the next year. We will be seeing it accordingly. Let's see further what are integers. Now integers is nothing but these are the types which are used to store whole numbers. For example, 345, 223, 1000, etc. These are further 4 types of integers in Java as shown in the slide, that is byte, short, int and long. The size and the description of which is shown in the slide. When we talk about a byte, its size is 8 bits, that is 1 byte. Short is 16 bits, that is 2 bytes. Int is 32 bits, that is 4 bytes. Long is 64 bits, that is 8 bytes. The values that can be stored in these depend on which data type is being used in the program. Now let's see what is float. When we know that integer data types can store only whole numbers, so they cannot be used to store decimal values. Thus the floating point data types are used to store fractional numbers, that is your decimal values. The floating point data types can be further divided into float and double data type. The the double data type takes 64 bits and it has a significance, it has a precision of 15 significant decimal digits, and your float data type is 32 bits and it has a precision of 7 significant decimal digits. Let's see what are character and boolean types. Now the character and boolean types are the 16 bits and it has a range between 0 to 65536 characters. That means it can accept these many characters. And a boolean data type has a size of 8 bits, that is 2 bytes, and it can be either a true or a false. Now children, once you have learnt about the Java concepts and the Java terminology, we will write our first Java program in the next session. I would also like you to do an assignment based on this, which I will be sending. Thank you.